Hi you guys, this is Mrs. Gall. I decided to do a separate video for two-step inequalities that one-step inequalities lesson was getting a little bit long. So here is your two-step inequalities lesson. Go ahead and title a new page, Two-Step Inequalities. Press play when you're ready to continue with the lesson. Alright you guys, I'm going to draw out most of our problems today just because there's a lot of fractions involved and I want you to be able to see those clearly. So here's our first problem we're going to try. M divided by 5 minus 11 is greater than negative 15. On the study guide and assessment, we'll ask you to sometimes graph your inequalities, but when we're going through these with notes, I'll usually graph almost every time. So what we're going to do is we're going to solve this inequality and then graph it. You guys, the solving process is just like solving equations. A reminder we talked about in one-step inequalities, the only difference is when you're multiplying or dividing with a negative number, then your sign has to flip. But otherwise, we don't have to worry about that. So let's go ahead and start by solving just like we would an equation. I like to draw a line down the middle. Whatever happens on one side of that line also has to happen on the other. Right now, I'm going to go to the side that has my variable. And I'm going to look for the piece that's furthest from the variable but on the same side, which is my negative 11. To get rid of this minus 11, I need to do the opposite of subtracting 11 and add 11. That makes my 11s cancel out, and I have m over 5 on the left is greater than 20. Oh, I'm sorry, that's a negative 15. I almost said 26, and that would have been wrong. Okay, so negative 15 plus 11, those are going to cancel out, so I have 4, and it's a negative 4 because I have more negatives there. Now we need to get m all by itself. Right now we see m divided by 5. The opposite of dividing by 5 is timesing by 5. So we're going to times by 5 on both sides to cancel out our 5's, to get m by itself. We're left with m is greater than negative 4 times 5, which is negative 20. Notice the sign didn't flip here because the number we timesed by was a positive. This one, it's okay if it's a negative. The only time we need to flip the sign is if this number here is a negative. Okay, so there's our answer. M is greater than negative 20. Let's graph it and then check our answer to see if it makes sense. A reminder that we graph by making a number line with 3 numbers. The center number is our number in our answer, negative 20. We go one up and one down on either side, so we have negative 21 and negative 19. Open or close dot? Well, when there's no or equal to, it's an open dot. Let's go back and see which way we're going to shade. M is greater than negative 20. Which values would be greater than negative 20? Towards the right, negative 19 and up. Let's find a number to plug in for m and see if this stays true. What's a number that's greater than negative 20 that we could plug in here? Notice we're dividing by a 5, so let's pick something that's divisible by 5. Maybe a negative 15. Let's try that. Negative 15 over 5 minus 11 should be greater than negative 15. Let's see if this is true. Negative 15 divided by 5, negative 3. Negative 3 minus 11. Could add the opposite there. Negative 3 plus negative 11 is negative 14. Is negative 14 greater than negative 15? Yes, that's true. So that means our answer made sense. We were just checking our answer there. If anything greater than negative 20 would work, and that did. All right, you guys, that is two-step. Oops, let's try another one. Negative 8 is less than or equal to 4 plus k divided by 3. Go ahead and write that down now. What would you do first here to get k by itself? Remember, we go to the same side as k and look for the piece that's furthest away from it. That would be our 4. To get rid of that 4, right now it's a positive 4. How would we get rid of it? Subtract it from both sides. -8 minus 4, or plus a -4, is -12. Keep the sign. My 4's cancel out. We're left with k divided by 3 on the right. How are we going to get k by itself if right now we have k divided by 3? Well, we can take k and we can times this side by 3. This is kind of like 1/3, and that's like a 3, so that's going to cancel those out. And we can times by 3 on the other side to get -36. Notice we times by a positive 3, so there was no sign flipping needed there. This is our answer. -36 is less than or equal to k. Let's graph it. 3 numbers on a number line. My center number should be -36. I go 1 down to -37 and 1 up to -35. I do a closed dot because it's or equal to, it could be 36. And then I shade. Let's look at our k. K has the open sign, the greater than facing it. So that means k should be greater than or equal to -36. So we're going to shade up towards values that are greater than. All right, you guys, a few more. This one's kind of an interesting setup. I'm going to write this one out for you. Go ahead and make sure you really get this one written down. W minus 2 over 6 is less than 10. These ones can definitely get tricky because of their setup. So when we have W minus 2 over 6 and we're thinking about how to get W by itself, the first thing we want to get rid of is the number that is kind of furthest from the W. So that's going to be our 6 here. And I know usually we add or subtract before we multiply or divide, but in this case we're going to do that multiplying or dividing first because that's the part that's further away from that W. So W minus 2 divided by 6, we want to get rid of this 6 first. Since we're dividing by 6, the opposite would be timesing by 6, and we're going to do that to both sides. That cancels out my 6's, and we're left with W minus 2 on the left is less than 60. Now we can get rid of that -2 by adding it to both sides. We're left with W on the left is less than 62. Graph that. Create a number line with 3 numbers. 62 in the center. 61 and 63 on either side. Open or close dot? Open. W is less than 62, so we're going to shade towards values that are smaller, towards 61. Let's find a number we could plug in here. I'm being really purposeful. I'm going to pick a number that I know is less than 62, but that will also kind of work out nicely for us. It's not always going to work out this nice. So we need something that if we took 2 away, it was divisible by 6, and it has to be less than 62. So there's a lot of options we could go with. Let's try 38. That's less than 62. So if we take 38 minus 2 and divide it by 6, that should be less than 10. Let's see if that's true. 38 minus 2 is 36. 36 divided by 6 is 6. Is 6 less than 10? Is that true? Yes, that's true. So that means our answer worked. This is our answer, and this is our graph that represents it. and we know that anything less than 62 should work in place of w. Why don't you try one of those on your own, a similar format? X plus 7 over 9 is greater than or equal to 5. Pause the video to try it on your own. I'm going to go through the answer quickly in just a second. Alright, you guys, just like the last one, the first thing you do is get rid of that bottom 9 by timesing both sides by 9. Cancels your 9's out, you're left with x plus 7 is greater than 45. Sorry, greater than or equal to 45. Now we get x by itself by subtracting 7 from both sides. You get x is greater than or equal to 38. Graph it. 37, 38, and 39 are my three numbers. Closed in circle because it's or equal to. Shading up for values that are greater than 38 or equal to 38. Okay, you guys, the last one we're going to do for this lesson is kind of a special one. Keep your eye out for something that might happen. Hint, hint. Negative 6 is less than 3 plus r over negative 4. Similar setup to the last few. So we're going to try to get rid of this negative 4 first. And to get rid of this negative 4, we need to times by negative 4 because we're dividing, and the opposite of dividing is timesing by negative 4. But anyone's bells going off? Look what just happened. We're timesing by a negative. What happens when we times by a negative? The sign has to flip. So now we're going to have a positive 24 is greater than 3 plus r. Let's keep solving by subtracting or getting this r by itself. So to get r by itself, we need to get rid of this 3. So we can subtract 3 from both sides. We get 21. Sorry, I don't know why I keep clicking that. Is greater than r. To graph that, we take our answer in the center. Open dot for greater than sign. Look at r. R has the less than sign facing towards it, so we're going to shade down towards 20. Let's see if that makes sense. Let's plug in a value for the original r and see if it works. So we're looking for something that's less than 20. I'm going to go back up here and rewrite out my problem. I know that if I add 3 to it, it's going to have to be divisible by a negative 4. So let's try doing something less than 21. That's if I add 3. Should we do 12? Oh, that won't work. 13. That will work. Okay, 13 is less than 21. And I think when I add 3 to that, that's going to work out nicely for me. So let's see. 3 plus 13 is 16. And if I take 16 and I divide it by negative 4, I end up with a negative 4. Let's see if this is true. Is negative 6 less than negative 4? Yeah, because negative 4 is closer to 0. So that was me trying an answer that was less than 21, and that was true when I plugged it in. So that means my answer of 21 is greater than r worked. Now, you guys, if we would have forgotten to flip our sign, and it would have been the other way around, if we would have tried something that was greater than 21 in here for r, it would not have worked when we went to check it. It would have been false. So that's why it's really important to check your work like this to see if it still remains true when you get all the way down. All right, you guys, that's all I have for this lesson on two-step inequalities today. Check in with your teacher if you have any questions.